441 minus 432, that's 9. All over 2. The square root of 9, that's on your list. You know, again, we know what the square root of 9 is. The square root of 9 is 3. So I'm going to cross this out and write a 3 next to it. So now we have x equals 21 plus or minus 3 all over 2. So now my two answers are right there. I got x1 and x2. So let's find x1. x1 is 21 plus 3 over 2. x2 is 21 minus 3 over 2. Okay? 21 plus 3, that's 24. Half of 24, that's 12. So x1 equals 12. x2, 21 minus 3, that's 18. Half of 18 is 9. So x2 here equals 9. Those are my two answers. Minus 4ac. It has a name. There's a name attached to this. This is called the discriminant. That's right. Spell it. Discriminant. Okay? The discriminant, all it does, it tells us what kind of answers we got coming. What kind and what type. What kind and what type of answers we got coming. So I got a 3-case scenario here. Okay? If your discriminant, when we compute it in the formula, if the discriminant is any type of negative number, if that b squared minus 4ac, if it's less than 0, then this tells me here I'm going to have 2 complex answers, 2 complex number solutions. If the discriminant, if we calculate it and we get 0, if it's 0, that means we got 1 real answer. 1 real answer. One real solution. Okay? If my discriminant is positive, then I get 2 real solutions. I get 2 of them. Okay? So these are the 3-case scenarios is when we calculate the discriminant to tell us what kind of answers we got coming. Okay? It don't tell us what the answers are. It just tells us what kind, how many, and what type we got coming. Okay? So let's do it. Let's do a problem like that, just so we know what kind of answer we got coming. I don't want to know what the answer is. I just want to know what kind. So we have this equation, x squared minus 14x plus 35 equals 0. Okay? If I want to know what type of answers I got coming, I'm gonna plug it into the discriminant. A is 1, B is negative 14, and C is 35. Just plug it in. So I have negative 14 squared minus 4 times 1 times 35. Negative 14 squared, if I square that, I get 196 minus 35 times 4, I believe that's 0.4. Subtracting 196 minus 140, that's 56. 56 is positive. So I got two real solutions. Okay? They're not rational. Okay? They're not rational solutions. Because I don't know what the square root of 56 is, because that's not on your list. The nearest square you have there will be 64. So this is like 7 point something. 7.8. Something like that to that degree. Okay, so this tells me here I got two real solutions. What they are, I don't know yet. Okay? So far, so good. Okay? So now that we know what they are, we know what they are, or what type they are. Let's figure out, let's determine what they are. Okay? We did a lot of work with this already, so I'm going to go ahead and I'm going to erase this here. So hopefully you all wrote it down. And I'm going to take it from the part that I have x equals. I'm going to take x equals 14 plus or minus the square root of 56 all over 2 times 1, which is 2. So I'm going to take it from right there, because we already calculated what the discriminant is. Okay? 56 is a positive number. It's a nice number, but it's not on your list. So again, we can break it down to find the perfect square that divides it, and the one that divides it is 4. So I can break this down. This is 4 times 14. I'm going to give you that little piece of it. 4 times 14 is 56. So this is x equals 14 plus or minus. The square root of 4, that is on your list. That's 2. So that's 2 times the square root of 14 over 2. Okay? Now, like most fractions, if I can go from reduction, we always reduce now, we ask questions later. So I can reduce that. I can pull a 2 out of there. So we're gonna use your factoring skills to reduce that. Because your math lab assignment is going to slam you if you don't. Okay? So I'm going to pull a 2 out of this. So the 2 comes out. I'm left with 7 plus minus the square root of 14 over 2. This 2 and this 2 cancels. And so I'm left with 7 plus or minus the square root of 14. So I have x equals 7 plus or minus the square root of 14. Okay? 14, again, that's not on your list. If it's not on your list, leave it. And now here's the thing. Whole numbers and radicals, they don't get down like that. I can't combine, because a number like this, under the radical, it wants to act like something that it's not. It wants to act like it's a variable. It can do any equation. Okay? As long as the equation is in standard form, I can work the formula. Okay? So, all I need to know at this point what A, B, and C are. Okay? A is 2, B is -5, C is 7. Okay? Now we can plug it into the formula. X equals. I have -5 plus minus the square root of -5 squared minus 4 times 2 times 7. All over. Make sure here that you draw that fraction bar over the entire top. All over 2 times 2. Now that we plugged it in, now we chug it out. X equals 2 negatives go positive. So I got 5 plus minus square root of -5 squared, that's 25. Minus 8 times 2 is, no, 4 times 2, excuse me. That's 4 times 2 is 8, -8. -8 times 7, that's -56. All over. 4. Okay? So, we subtract. 5 plus minus square root of, I believe that is -31. Yeah. Over 4. Now, we have a problem. What seems to be a problem we have. Up until now, every number you came across in your math class, from kindergarten to this point, has been a real number. Okay? We cannot take the square root of a negative number, because when you square a negative number, it turns positive on you. So you say, hey, give me a number that when I take the square root of it, it's negative. That's not going to happen. So now we're going to introduce to you a new idea, a new concept here. Remember, and I asked you and last week we talked about DC versus Marvel universes. Okay, all this time we've been working in DC. Now I'm going to switch you over to the Marvel universe. Okay, and this will be our bridge to do it. We're going to talk about the imaginary number system. Imaginary numbers. I'm going to write in here the complex number system. Okay? Because all these here are complex numbers. Okay? The reason why they're complex is because we don't know who made this up, where this came from. It just is. So just like many of the heroes in the Marvel universe, they're mutant powers. They're like, well, where did this come from? How did this mutation? We don't know. We don't know who got the mutant gene. We don't know who did it affect. It just affected everybody across the board. Okay? Whereas opposed to DC, the heroes in DC, they were people of status. Like Batman, he was a rich playboy. Rich playboy turned superhero. Wonder Woman was a princess who betrayed her mom's wishes and became Wonder Woman. Superman was the son of the jailer of Krypton. So all these people were like people of status. They had status. They had access. They had clout. Marvel heroes, however, they just anybody. Anybody that the mutant gene fell on. Spider-Man, he wasn't a mutant, but he became one just at random. It just spider fell on the bed and bam, Spider-Man, there you go. And Spider-Man was poor. The DC heroes they had a little money on them. Or they had access to get money, to get wealth. Marvel heroes, they were poor. They were outcast by their families and their friends. Oh, you a mutant, get away from me. Ugh. Yeah, that type of thing. Anyway, the complex number system. We're going to use this definition. The I, lowercase I, is equal to the square root of -1. That's the definition of what an imaginary number is. So we're going to use this definition. Because this will get us over into dealing with that. So now we have a whole new set of numbers to play with. Which like the imaginary number or the complex number system. So this becomes x equals 5 plus or minus I radical 31 over 4. And I can leave it like that because 31 is not on your list. As far as I take the square root of 31, I don't know what square root of 31 is. Okay? So it's not on your list, so I'm going to leave it. The I comes out because the negative is under the radical, so I pull that I out of there. So now your answer is complex. That's a complex number. Okay? It contains both DC and Marvel together. So that's the kind of universe that we're in. We're going to throw in all the heroes from both universes together. There you are. To make the real number system. Because the real number system, now you have the complex numbers. Okay? And when I say complex, we're talking A plus BI, where A is the real number part and B is the imaginary number part. So A plus BI. Did that make sense? Okay? It'll make better sense when we continue just working with the complex number system and the complex numbers. Because what